Machines have the ability to learn, and they have the ability to be creative, and they also have the ability to see. Humans have vision. That's what makes us so powerful. So computer vision is one of the most impactful industries in AI. So today I'm going to be quickly showcasing two computer vision algorithms that I've made. One is facial tracking, and one is going to be doing object detection. So I'm going to do quickly facial tracking using Viola-Jones algorithm. So here I have my webcam, and this is the actual facial tracking algorithm. So it's going to look for my face, it's going to look for my eyes, and it's going to look for my mouth. So as you can see, it tracks, and it does that. And it can track multiple people at the same time, so that's pretty cool. So how does it work? So as you see here is a very beautiful man. And what's going to happen is we're going to use something called HAR-like features. And it just looks like this. So they're basically just black and white edges, corners, lines, and they're used and they can be scaled and put on an image. So first thing we got to do is we got to make the image grayscale. Now the reason is because when you have a colored image, you have three-dimensional arrays. So you're going to have a value for red, a value for green, and a value for blue. But if you convert it to black and white, you're only going to have values from 0 to 255. So what we're going to do is we're going to iterate through the image, and we're just going to go through the whole image, and then we're going to find the features. So we have the HAR-like features. So what we're doing in this step is we're looking for edge-like features. So for example, if you take my eyebrows, we have black and white. And what it's going to do is as it's iterating, it's going to take the average of whiter values and blacker values. And what it's going to do is it's going to take the summation of those and subtract the summation of the white from the summation of the black. And if the average passes some sort of threshold, it's going to put a HAR-like feature on it, just like it did on my eyebrows. And once it's classified the features and it recognizes there's a face because there's a lot of features, so there's the eyebrows, the eyes, the nose, and the mouth, it's going to say, well, this is the face. So it tracks your eyes, your mouth, and your face. And we have different rectangles allocated to those features. And then you just finally overlay the color back onto it, and then you can just have a facial tracking algorithm. So next I'm going to show you object detection with SSD. Just going to go here, and I'm going to show you just a little bit of this video. So as you can see here that it's tracking cars and people, and it's not the greatest. Sometimes it's mistaking that billboard for a car. And as you can see, it just tracks frame by frame, and it's looking, that's a car, and it's, as you see, it's going to start tracking other things like potted plants and stuff like that. So I'll just show this for another couple seconds. And that's that. So how does that work? So SSD is single shot detection. You've probably heard of YOLO, YOLO v2, YOLO v3. SSD is just another algorithm for object detection. Now the way SSD works is it will take an image and it's going to place dots in a grid shape. And the reason why this is sometimes proclaimed better than YOLO is because it scales better. So what we do is we apply shapes around these circles. So now I can have a square, I can have a rectangle like that, and I can have another rectangle like that. And what happens is I can change the number of shapes I have on top of it, or I can change the ratio, the scale, whatever. And that's why the scalability of SSD is usually known to be better than YOLO. And then we apply this to all the circles. And then it's going to look through all the images, and using machine learning, what it's been told is what looks like a person. It's going to classify these two as a person. So we go here, and it's going to look at it. And now some squares will see we have legs. So they're going to predict, well, above the legs, there's probably going to be a body. One rectangle might see there's a head. So one rectangle is going to say, well, there's probably a body below the head. And that uses that prediction and uses machine learning to classify what that object is. And in this case, it classified it as a person. So computer vision is one of the leading industries in AI today, and it has the biggest impact. It's being used in self-driving cars, gesture recognition, facial tracking, and object detection. So I believe that computer vision is essential because as humans have vision, we would be nothing without it. So AI needs to have vision to fully have its potential to reaching artificial general intelligence. Thank you.